This video is on doing calculations using the speed of sound. Before we start off, you need to know that there are two different equations that you will be using to solve these different types of questions. The first one is the relationship of speed is equal to frequency times wavelength. And the other one is the speed of something is the distance covered divided by the time it takes. The one different thing that we'll be doing with these equations than we've done in the past is you are always going to use a V of 340 meters per second because that is the average speed of sound in air. So I will never ask you to solve for V, which is speed. If you're using the first equation, I'll ask you to solve for either frequency or wavelength. Using the second equation, solving for either distance or time. If you struggle with using the equation as is to solve for something else, then remember that they both have a triangle that you can use for rearranging. For the top one, V is at the top, frequency and wavelength are in the bottom corners. And for the second equation, distance is on the top, and speed and time are in the corners. And so keep those in mind as we go through the note examples. This would be one example of using the first equation. It says, what is the wavelength of a sound? So I'm asking you for the wavelength if the frequency is 1500 hertz. So this is frequency. And the question often comes up, how do I know which equation to use? Well, this one is giving you a frequency. So I have to use the equation that shows frequency. So I will be using the top equation. If I start with the rearrange, since I'm trying to find wavelength, I would do wavelength is equal to frequency, is equal to speed over frequency. And again, for all of these calculations, V, or speed, is 340 meters per second. And this would be over 1500 hertz. And then you would complete the math. Sorry, I don't have my calculator up. So 340 divided by 1500, and you will get 0.22666, so 0.227, and wavelength in this case would be measured in meters. So this one is a fairly straightforward calculation, very similar to the calculations we did in the last unit with waves if I was asking you to find wavelength or frequency. The other style of questions is using the speed as distance over time. And these ones all involve echoes. And so what I do with these is there's an additional step. And sometimes it helps if you draw a picture. So if you can imagine, as it says in the question, that you are standing in front of a brick wall. Here you are standing in front of a brick wall. And you are going to yell at the wall. The echo is going to take 0.75 seconds to get back to you. Well, if you remember how an echo works, it's a reflection of the sound wave. So the wave will leave your mouth, bounce off the wall, and come back. And that whole process will take 0.75 seconds. Now, the reason there's an extra step for this equation is because you should realize that if I use 0.75 seconds in my calculation, I would be getting the distance there and back. And I do not want the distance there and back. I only want the distance there. Since sound waves travels at a fairly constant speed, you would just need half of that time. So you would take 0.75 seconds and divide it by 2 to use in the equation. So if I go back to that equation, it says how far. That means I'm trying to find a distance. So if I cover up distance on this triangle, I would have that as speed times time. So distance is equal to speed times time. Again, the speed of sound is 340 meters per second. And the time I would use is half of that 0.75, which is 0.375 seconds. And when you multiply those two together, you will get a distance of 127.5, and distance is measured in this case in meters. So if you can remember that when I'm finding distance, I divide. That'll help you remember that. If I'm finding distance, I'm going to divide. Distance, divide. And when I talk about divide, I mean divide that number. What if I'm finding the time? It says you're standing on a mountain and you yell, and the next peak is 275 meters away. So here's my mountain peak. Here am I on this other one, and I'm going to yell, and it's 285 meters to this mountain peak. How long will it take the echo to come back to you? Well, again, remember, the way an echo works is your sound leaves you, it goes to the other surface, bounces off, comes back. So the sound from your voice or my voice standing on the mountain for that echo, it'll leave the mouth, it'll travel 285 meters, hit the surface, and come back another 285 meters. So in this case, you would have to double the distance or take it times 2 because it would actually have to travel there and back. So you'd have 285 times 2 to get the actual distance that you would use in this calculation. So if you were to go back to the triangle, you'd find that time is distance divided by speed. Again, you're going to use a distance of the 285 times 2, which is 570 meters, divided by the speed of sound, which is 340 meters per second. And so calculating that, you would get a time of 1.676, and time is measured in seconds. Let me write this a little bit better because I got kind of sloppy there. 1.676 seconds. So if you're trying to remember, keep this in mind. When I said on the last one, if you're finding distance, you divide D and D. So if you're finding time, you're going to times. You get T. So if I'm going to find the distance, I divide ahead of time before. So I divide that number that it's given me before I put it into the calculation. If I'm finding time, I need to multiply by 2 before I plug it into the calculation. If you don't want to try to remember that and you want to draw the picture, that's helpful. Like I said, I almost always draw a picture to myself, or at least think of that picture in my head to help me solve these style of questions. So now you should try the assignment that says speed of sound problems. And if you have trouble, make sure that you ask for assistance in class.